let's continue section 4.1, simplifying algebraic expressions. So we were just doing example number 12 when I got cut off the last time, and we were verifying that indeed these two expressions that we had created by using the distributive property were equivalent. So we had shown with 0 they were equivalent, and we were about ready to show with 1 that they were equivalent. So 1 plus 3 using the order of operations is 4. Don't forget the parentheses, and that shows us multiplication. 2 times 4 is equal to 8. And then over here, 2 times 1, which is equal to 2, plus 6, which is indeed equal to 8. And there you see it. We have it verified. And now we'll do it one more time with the -1. So 2 times a -1 plus a 3. And then we're asking, is that equal to 2 times a -1 plus 6? And again, verify using order of operations. -1 plus 3 is 2. Put that in parentheses. Multiply it by the 2 out here. 2 times 2 is 4. Then over here, we're going to find out, is this equal to 2 times a -1, which is a -2, plus a 6. And -2 plus 6 is 6 minus 2, which is indeed 4. And there you have it. These verify under 3 circumstances. So what we see is that these are equivalent expressions. All right, now let's move on. So we have quite a few problems here that will take us through combining like terms. So I'm going to do as many of these in this video as possible. Wherever I run out, then I'm going to assume you have been pausing and going through each example after you've tried to work it on your own. You might want to listen to the first one with me and then do the other ones on your own. But there's quite a few examples here, and there's a few little nuances in each of them. So this may take us a couple of video lessons to get through. All right, so the first one I'm going to do is 2x plus 4x squared plus 5x minus 2x squared and then plus 5. So I'm going to actually, on this very first example here, totally use our distributive and associative properties. Or excuse me, not distributive, but the associative and commutative properties. So this is going to equal, and I'm going to find all the x squared terms and I'm going to put them first and together. So 4x squared, I'm going to put that up front, and then plus, and I'm going to make this plus a negative, right? So that's plus a -2x squared, because remember the first thing we want to do when we're simplifying algebraic expressions is change everything to addition. And that's all my x squared, so I'm going to associate those, and then I'm going to say plus, and now I'm looking for x terms, so I'm going to have the 2x that I saw first, and then the plus, and then the 5x that came next, and then I don't see any x terms anymore, so I'm going to finish those, and then plus, I see one lonely 5, and I'm going to put that outside by itself. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Make sure you got them all. And now what I'm going to do is I'm going to be adding these things up, and the way you do that is you look at this one and you look at this one. It's the numeric coefficients. I have these things, these x squareds, and I'm finding out how many of these x squareds I have. That's what it means to combine like terms. So I have 4 of them, and I have plus a -2, and so I have a +2 of these x squared terms. Plus, I have 2 of these and 5 of these x terms. 2 x's and 5 x's. So how many x's do I have? Well, I have a total of 7, and those are 7 x's. So plus 7x. And then the constant, it just hangs on. And there we are. There's a simplified version. Now your book